New Year Dancer was created by direct construction in Victory Brown microcrystalline wax. Microcrystalline waxes are petroleum-based byproducts and are the waxes most commonly used by sculptors for the casting process. Various elements were made by pouring wax onto a plaster bat and by sloshing wax into a variety of plaster molds. A plaster bat can be made by taking a plaster mold from a 1/4-inch sheet of glass. The bat is soaked with water until it is thoroughly saturated. The excess water is sponged off. When pouring the wax into the mold, you should change the direction of the flow continuously. If you were to concentrate the flow of the wax in one area, you will probably get lap lines and quite possibly burn the bat. When the wax has cooled, it will shrink slightly and can be removed from the bat. Mold sections are immersed in water until they are completely saturated. The way you can tell when a mold is thoroughly saturated is to look at the surface of the water. When you do not see bubbles rising from the mold, it is saturated adequately. Remove the mold sections and drain off any excess water from the surface. You can bind the mold sections together with a length of rubber. This one is cut from a bicycle inner tube. If you wrap the rubber tightly over high corners on your mold, it will not slip and you will not have to tie knots in your strap. The best way to melt wax is in a cooker fryer or a crock pot with a temperature control. The wax should be approximately 180 degrees to prevent excessive shrinkage and reduce the chances of burning the surface of your mold. If you do not have a wax pot with a temperature controller, you can check the temperature visually. When you have wax in a pouring container, tip the container so that wax runs up on the inside of the container. If it lays up very slightly on the inside, it is at the proper temperature and is okay to pour. If you tip the container and the wax runs down quickly without leaving any residue, it is too hot. If you pour wax that is too hot, you will probably burn your mold, or at best have an element that is too thin. You should only have to slosh a mold 6 to 8 times to achieve 1/8 of an inch thickness if your wax temperature is at 180 degrees. Do not wait too long between pouring out and pouring in the next layer, or the wax will probably not adhere to the previous pour. This can be a problem when you start slicing the wax because it will separate at each pour. Check the thickness of the wax poured by slicing away part of the wax. If you notice that it is not thick enough, push the section back down and continue to slosh 2 or 3 more times until you get 1/8 of an inch thickness. Always use a contained pot for wax, never a hot plate. wax is quite flammable and can reach a flash point, bursting into flames. If that occurs, smother the wax. Do not try to extinguish the flame with water. If the wax is ever smoking, you obviously reached a temperature that is much too hot and is nearing the flash point. Good ventilation is extremely important also, especially when welding wax sections together. You may wish to wear light gloves when sloshing wax out of molds. In the event that you get hot wax on your skin, if you do get hot wax on your skin, don't try to peel it off. If you peel the wax off and it's too hot, you're going to remove the first layer of skin. Instead, immediately place your hand in cold water, or better yet, cool the wax with ice. This mold was made from a revamped spool that weaving yarn is wrapped on. A two-piece mold was made, and many elements were poured to create the form for the finished piece of sculpture. Half a mold was taken from a rubber ball to obtain smooth round sections. This piece was constructed so the wall thicknesses and seam thicknesses were consistent. All the seams must be welded together from the inside and outside. Some smaller segments of the piece were made with consideration for access to the inside seams of all elements. A wood burner, soldering iron, or sign painter's stencil tool can be used to melt seams together. The inside is done first, then the outside. The outside is penetrated with a hot tip and filled with filler wax. Filler rod is simply thin strips of wax cut from a sheet of wax. The surface was then scraped to clean the form. Every sculptor has their own way of working and their favorite tools. Many sculptors use tools for working wax that are commonly used by potters for trimming. Flat blade tools, wood modeling tools, and wire trimming tools are excellent for working wax. One of the best tools is simply a paring knife. Tools also can be revamped by grinding or filing to meet your specification. Often store-bought tools don't conform to your needs. As you work, you'll find what tools work best for your aesthetic purposes. Some sculptors work with heated tools rather than wood-burning tools. They may heat the tools over a propane torch or alcohol lamp. I've even seen tools heated over a candle. want to make sure that all of your seams are the same thickness as the rest of the piece. Here we have the upper section. You'll notice the darker wax where the sections were welded together. This ball shape was added to the bottom by filling in the seam and then carving away the excess seam wax. In this particular case, I wanted to remove a little of the upper and lower sections to reduce the form of the sculpture in this area. I scribed a mark around the forms and cut the unwanted pieces off with an X-Acto knife. I find the X-Acto knife with a number 11 blade to be a valuable tool, not only for slicing off sections for proper alignment of a joint, but also for making wax welding rods. I work on glass or a formica surface when I'm working with wax. The hard, smooth surface of glass or formica allows me to easily scrape off any drips from welding or sloshing a mold. Also, I work with a mirror, so as I'm working on a piece, I can see the other side of the piece in the mirror. I find it easier to read profiles that way. You can see most of the piece assembled. Darker areas on the piece are where joints were made. And this is the seam where the piece will be welded together once the piece is in bronze. Further fabrication of the lower part of the piece. A cut line is marked on the lower form where a section of wax is to be removed. Masking tape is placed on the piece to act as keys to assist with alignment once the unwanted portion of wax is removed. Once this plug is removed, the two sections can be put together with the masking tape keys to assist in lining up the form. The cut line is 1/8 of an inch in, indicating the thickness of the section to be attached. This seam then is welded, making sure there's good penetration all the way in to where the two pieces of wax come together. One of the most common problems people have when working with wax is that they become impatient and move a piece too soon after welding a seam. You should let your joints completely cool before moving or cleaning, or they will not hold together. The inside was checked and scraped to remove excess wax, or more wax was added in order to achieve a consistent thickness. This was the final weld on the piece, and the seam was still accessible from the inside to check to see that I had a good penetration and proper thickness. A horizontal tape was applied so that any excess wax that ran down would remain on the tape and could easily be pulled off. The wood burner goes all the way through the thickness of the wax to ensure a solid weld. Once the seam is welded all the way around the joint, the excess wax from the weld can be cleaned off. If you do everything correctly in bronze casting, you should be able to pick up fingerprint detail in the final casting. So sometimes you may consider leaving tool marks in the wax pattern as a textural contribution to the piece. Both wax sections completed. Now I'm ready to construct a gating system. The gating system for this piece will be attached after the core is poured. This plaster mold used to make gate material was made off 3/4 by 3/4 inch lengths of pine. Because the mold is channeled down and across the bottom, wax can be poured into one opening of the mold. Once this wax is cool, the mold is opened and the square gating material is removed. It is also possible to purchase gating material should you elect not to make your own. The use of square gates reduces the spin of metal when it is poured into the investment mold. If you have round gates, the metal flow can spin and become turbulent, causing deterioration of the mold cavity. Vents are made by plugging both ends of plastic drinking straws and then dipping both ends in wax to seal them. Once the straws are cast in bronze, you could use the bronze straws as welding rod. By doing this, you would be welding with exactly the same metal as your casting and eliminate the possibility of discoloration that would occur if your welding rod were of a slightly different alloy. Cocktail straws are especially good because they're about 1/8 of an inch in diameter. Flexible straws are often used and are quite valuable in areas where you need to go around gates or other parts of a form. The gate should taper down to the thickness of the pattern at the point where it is to be attached. If you had a thick gate attached to a thin area, you would have shrinkage at that point. The thicker the metal, the longer it stays hot and shrinks more than thinner areas. Often gating systems are fabricated right on the piece. In this case, because we're going to pour the core first, it is much easier to fabricate the gating system in the studio and attach it to the pattern after the core is in the pattern. Large plastic cups are used to form the pouring cup. A good pouring opening is desirable because when pouring bronze, you want to fill the mold as quickly and smoothly as possible. If you use a small cup, you could still pour the mold, but you wouldn't get the metal into the mold as fast as you should. A large cup is obviously easier to hit and will allow more pressure, so the mold is filled quickly. The investing process starts with the measure of dry materials. This is a 5-part formula, so we have marked off our measuring bucket in 5 equal parts on the inside. To facilitate the mixing process, the ingredients are dumped on the floor and then turned over with shovels until all ingredients are thoroughly mixed. Notice the use of a dust mask. The formula we commonly use is 5 parts molding plaster, 5 parts silica sand, and 2 parts vermiculite aggregate. Fine perlite could be substituted for vermiculite, and round sand substituted for silica sand. It's a good idea to keep a sketchbook of all the patterns that you make, recording where the gates and vents are attached to the pattern and the weight of the pattern. The wax to bronze ratio is approximately 1:8. For each pound of wax, you would need 8 pounds of bronze. We always use a 1:10 ratio to ensure that we have enough bronze to fill the mold, taking into account that there may be flashing and to cover any spillage. So 1 pound of wax equals 10 pounds of bronze. When mixing investment, always use cold water. Add the dry investment quickly to the water until you have a mound of investment peeking up out of the water. Then mix by breaking up any lumps while stirring quickly, being sure to keep the sand suspended off the bottom of the bucket. Don't mix investment as gently as plaster. When you pull your hand out of the investment, you should have an even, opaque cover on your hand. If you cannot see your skin through the investment, it is ready to pour. The core is poured with several small amounts of investment. If you had a large core and were to fill the entire core at once and had a weak seam, it could burst the wax pattern. Never use warm or hot water to mix investment. It will cause the mixture to set too fast, reducing your working time drastically. If you don't have enough dry ingredients in your mixture, you'll have a very weak mold. It may set up, but you'll get much more flashing. Thick investment will not flow completely around the piece or in the core, causing air bubbles. So when bronze is poured into the mold, those air bubbles will fill with metal, causing plus metal on the surface of the casting. When you pull your hand out of the investment and can just see your skin through the investment, adding small amounts of dry investment is better than putting in a big scoop. Here, core pins, which are 6-penny nails, are pounded through the wax pattern into the set core. The core pins stabilize the core once the wax is burned out of the mold. Dead vents or dead drains are attached. When mold is poured, any extraneous particles in the mold will be pushed by metal to the lowest points in the mold. The Dead vents allow extraneous particles to be pushed beyond the sculpture, reducing the chance of imperfections in the sculpture. A felt paper cylinder is prepared. The felt paper should go past the seam 1/2 times around, providing a safe and strong overlap. Duct tape is used to seal the seams. Make sure the duct tape is thoroughly rubbed down so that it strongly holds all seams. On a larger mold, you would want to make 1 or 2 wrappings of duct tape around the cylinder to ensure its holding strength. The piece has been sprayed with Murphy's oil soap to act as a debubblizer. 1 part Murphy's oil soap to 3 parts of water works very well for us. But we have also used other liquid soaps with success. The soap makes the surface of the wax compatible with the investment and helps reduce the possibility of air bubbles forming on the surface of the piece. A small batch of investment is mixed to hold the cylinder so the investment will not leak out from the bottom. You could use plaster, but I find it easier and more economical to use investment. Investment is mixed and poured. If your investment is too thin, you'll see the vermiculite floating on the surface. As you can see here, we have a good homogeneous batch. Usually, you should have 2 people helping you when you invest. 1 to help run buckets to fill them with water. Water should be about 1/3 up in the bucket, and 1 person to assist you invest. The quicker you get the piece invested, the better the surface will be. Try to avoid a lot of movement or vibration of the pattern when investing. That will cause bubbles on the pattern surface. But if you take your time and pour investment too slowly, you'll get lap lines on the piece. There are many ways of investing a piece. This is one method for this particular piece. Some pieces are gated and then simply immersed into a sealed cylinder containing liquid investment. Some drawings and explanations of other investing procedures will follow later. The mold is turned over and the bottom of the pattern is revealed so it can be cleaned up so the gates and vents can be attached. This is the gating system that was fabricated earlier. A wood burning tool is used to slide under the gate to meld it to the pattern. This is an easy and comfortable way to attach a gating system because the pattern is stabilized for you. Notice the taper of the gates at the point where they enter the pattern. This is called top gating. Even though the pattern is upside down, the metal will go in from the top of the mold. Any excess wax that dripped off the gate is trimmed and cleaned up from the mold so the metal can flow smoothly into the cavity. Any high point on the piece has to have vents. For instance, a portrait with a nose or chin that points up toward the cup must be vented, because if it isn't, air will be caught in that spot, and vents serve the function of letting any gases or air out of high points so the bronze can completely fill the cavity. A flat tip on the wood burner will allow you to touch underneath the straw to melt the wax on the end and pop it on. Structurally, you're better off if you weld the vents together at the top. There's less chance of them breaking off when the investment is poured into the mold and they begin to vibrate. This is the completed gating and venting system. The mold now is wrapped with chicken wire. Chicken wire is necessary to keep the mold from breaking. If you didn't have chicken wire in a burned out mold and you picked it up and turned it over, there's a strong possibility that the mold would break in half. With the chicken wire, it adds structural reinforcement, and if you have cracks in the mold that go horizontally, the chicken wire holds the mold together, and at worst, you have flashing. Flashing is where a mold cracks and the metal runs into that crack. A cylinder felt paper is built and dropped over the initial mold. There's about an inch opening around this mold now. An investment curb is built up, and after the curb sets, investment is poured again. Once the mold is completed, the top will be inscribed with the name of the sculptor and also the amount of bronze that is required to fill the mold. In this case, 19B is to indicate that 19 pounds of bronze should fill this mold. Trim off anything that is extending from the mold. There's no sense to burn up extraneous materials if you don't have to, and it's desirable to have a flat surface on all molds for placing them in the burnout kiln. Often we have a lot of molds and they have to be stacked one atop another. If all molds have flat surfaces, it is easier to stack them, reducing the possibility of a mold falling inside the kiln or cracking because it cannot be supported evenly. The core is being poured into the bottom section of the piece. As said before, the core, when investing like this, should be poured in several layers. There were 6 or 7 layers of investment poured into this core. If you pour the whole core at one time, you're liable to warp the form at best and pop a seam at worst. These nails were added to give the investment core a little more adhesion to the outside investment when it is poured over the piece. When core pins are placed in a piece, they should be placed at high points on the form that are accessible. When the casting of the piece is completed and it comes time to remove those pins, you'll want to have access to pull them and fill them, either by welding or plugging with screws. Pouring cup and gates are attached, and vents are being placed here. Again, it's a good idea to attach the vents at the top to give them more structural strength. The piece is sprayed with water-diluted soap, which acts as a debubblizer. Alcohol can also be used for this purpose. Felt paper cylinder is fabricated and placed over the piece. A curve of investment is placed around the cylinder, and after it has set about 15 minutes, investing may begin. There's duct tape over the opening of this cup because this mold is relatively sizable and the investment must be poured quickly. The duct tape is there to prevent any investment from entering the cup. If it does, you just have to dig it out, but this reduces the chances of filling the cup with investment. It took about 15 minutes to fill this cylinder. You can mix small amounts of investment as long as you pour them quickly. As said before, if you wait too long between layers, the result will be lines of separation on the casting, and it also could result in flashing at those points. Once the investment is set, the investment curb is broken off and the felt paper removed. If you're careful with removing the felt paper, oftentimes you can reuse it. The vents are trimmed and the cup is pulled out. The mold is turned over to reveal the bottom of the pattern. Any dust or excess investment is cleaned and a series of dead drains are attached. Chicken wire is wrapped around the mold to give it structural strength. Felt paper cylinders are most commonly used for containing investment, but we have cast small pieces in steel pipe. I've fabricated boxes out of sheet steel reinforced with angle iron for casting reliefs. And we often use coffee cans for small pieces. If you use coffee cans, you want to cut the bottoms out so they're open on both ends. When using metal containers, you can eliminate the use of chicken wire reinforcement. A felt paper cylinder is placed around the form, and a curb of investment is built around the base of the cylinder. You don't have to make huge molds. If your outer retaining cylinder is about 2 inches at any point away from the pattern, you should be safe. Once you invested your molds, you can place them in the kiln within 15 or 20 minutes after setting. I like to put my molds in a kiln for burnout shortly after investing, because I feel the steam that is released from the mold during burnout helps to vacate the wax from it. This illustration shows the molds placed on the floor of the kiln and elevated on fire bricks. The gating system is indicated in red. Notice how the core pins go through the wax into the core. In this case, the core pins are 6-penny nails. Smaller cord pieces can utilize thinner nails, and larger pieces require nails that are thicker. I found that the 10-penny nails were the largest nails necessary for very large castings. The molds are burned out at 800 degrees. Once the 800 degree temperature is reached in the kiln, it is maintained and the molds are burned out for 24 hours per foot in diameter, using the largest mold for measurement. This illustration shows that the wax has been completely vacated. You can see how the core pins stabilize the core so it cannot move. This drawing is of a piece that has been gated and will be immersed in investment. Notice the vent off the chin that rises to join the other vents. Any high points pointing up toward a cup must be vented. An investment seal has been poured to seal the cylinder from the inside. After that, investment sets. Liquid investment is poured, the piece immersed, and additional investment poured into the core while filling the cylinder. Once the investment is set, the felt paper is removed and the finished mold is ready to be trimmed, inverted, and placed in a kiln. This is a plastic car model that has been thickened to 1/8 of an inch by painting wax onto the inside of it. This piece would be invested after stabilizing it. You'll notice that the cup and vents have been sealed to a piece of paper. The felt paper cylinder and chicken wire reinforcement are placed over the pattern. The cylinder is sealed from the outside, and when the curb has set, investment is poured over the pattern. The bottom drains go completely through this model, enabling heat to flow through it during burnout, helping vacate the plastic. When the mold is burned out, those vents are plugged with bronze vents of the same diameter available from a previous pour. When the bronze enters the mold and hits the bronze plugs, they chill, preventing the flow of bronze beyond that point. These are examples of how simple gating and venting can sometimes be. They are solid wax patterns, so no core pins are necessary. Nothing is pointing up at the cup, so none of them need vents. All of these pieces, the largest being 8 inches, could have the cup sealed to a piece of paper with melted wax and sprayed with water-diluted soap to avoid air bubbles forming on the surface. Felt paper cylinder and chicken wire placed over the individual pieces. Bases of cylinders sealed with investment curb, and then investment poured into the container. They could also be immersed into a sealed cylinder of investment and held there for a couple of minutes until the liquid investment sets. These are the same pieces, but showing how they would be gated if you wish to bottom gate them. The torso to the left has high points at the legs, so those points must be vented to allow wax to flow out during burnout. If all wax is not vacated from a mold, it remains moist, and when molten bronze enters the mold, it will violently erupt from the mold, resulting in a lost casting and creating a serious safety hazard. If by chance the piece would pour without vents, you would lose 1/4 of the piece, because contained air would stop the bronze from filling the cavity. The same thing applies to the little relief. It's a little bit high at one corner, so you run some vents off that corner. The hand likewise. In bottom gating, metal enters the cup and travels to the bottom gate first. The flow of the metal continues upward through the piece in any following gates. Once the molds are burned out, they are removed from the kiln and prepared for pouring. I like to pour molds at room temperature. You really should not be working with a mold that is any hotter than 200 degrees. Hotter than that, they are difficult to work with and can result in burns. At this point, we are careful to avoid getting waste or sand into the molds. Once we take the molds out of the kiln, they are vacuumed while they are suspended with the cup down, so we don't turn a mold over and drop any particles of investment that were on the mold into the cup. Vacuuming the mold is extremely important, particularly if you have burned out wood, plastic, or other materials that could have ashes in the mold. At this point, the mold is turned over, so the cup is up. Any shards of investment are then vacuumed off. The mold is then covered with a layer of craft paper tightly sealed with tape. The name of the artist, the location of the cup, and how much metal required to fill the mold are written on the paper covering. It's important to know how much each mold is going to require. There's no fun in pouring 10 pounds of metal into a mold that requires 20 pounds. I'd rather have 15 to 20 pounds of excess metal that can be poured into ingot mold than be just a pound or two short. The molds are placed in a pit of sand that has been moistened slightly for ramming purposes. You must be very careful with water around molds. If sand is too wet, what could happen is that the moisture from the sand could permeate the molds, and when bronze is poured into them, steam would form, causing the bronze to spit back out violently. The molds are rammed in sand, so if one of the molds cracks or some metal spills, it is safely contained in the sand. The crucible is preheated in the furnace. The fuel for the furnace is simply a mixture of air and natural gas. Bronze should be melted as expediently as possible. The faster the metal is melted, the less oxygen is apt to get into it. The bronze ingots are all weighed and marked for weight so we know how much metal we'll have in the crucible. We use silicon bronze as it has long proven to be the best bronze for casting purposes. The ingots are placed on the furnace lid in order to warm them and to drive off any moisture. If a cold ingot were introduced into a crucible that contained molten metal, there would be a violent reaction, a virtual explosion of metal flying up and out of the crucible. If you had ingots that have been stored outside or in a cold storage area and put these ingots on top of the furnace, you would see moisture form on them. All metal should be thoroughly preheated before introducing it into a crucible. It is essential to ensure proper safety practices in the foundry. Here, the ingots and skimmers are treated with acetylene to preheat them and coat them with a layer of soot that will keep them from having metal stick to them. They'll then be put near the furnace for further heating. When dressing for pouring metal, boots should be worn, preferably leather steel-toed boots. From the boots up, everything should be layered. If some accident should occur, it can happen if you pour molten metal into cold ingot molds. That molten metal will explode and will act like shot flying through the air. If a glove is outside of a jacket sleeve, it could catch and trap metal and cause severe burns. There should be no areas where metal could get caught. Everything you wear should be layered. Our pouring temperature is 2000 degrees. We try to maintain that regularly. If you pour metal that is too cold, you'll get incomplete castings. If you pour metal that is too hot, you'll get shrinkage and tearing, where the castings virtually pull apart. The paper covering is torn back, revealing the pouring cup. Being careful not to get any shards of sand into the mold. The bronze has reached 2000 degrees. The crucible is pulled from the furnace with tongs and placed into the pouring shank, which has a small piece of cardboard under it to keep the crucible from sticking to the kiln shelf beneath it. Any slag that is on the surface of the metal is skimmed off and we're ready to pour. The excess metal that is left in the crucible is poured into warmed ingot molds. This was a good pour. All molds received a steady stream of metal. There was no dribbling of metal into the molds. The person using the skimmer held back any little particles of slag that may not have been skimmed off the metal. This was a good clean pour. The crucible is put back into the furnace. A piece of cardboard is dropped in to keep the crucible from sticking to the base block. A piece of kiln shelf is placed over the port of the furnace to keep as much heat in the furnace as is possible. This allows the crucible to cool slowly to avoid cracking it. The gas and air valves are turned off and a cover box placed over the fan to keep dust out of it. The molds are left to cool, and the next day breakout can begin. The molds are removed from the sand pit. If you don't have a sand pit, the molds can be placed in steel barrels with both ends off, and sand can be packed around the molds. A hatchet is used to notch the mold and cut the chicken wire support, being careful not to go too deep into the mold to avoid striking the casting and scarring it. Once the casting is removed from the main body of investment, the nails that are acting as core pins can be pulled. You can see the cup, gates, and vents transformed to bronze. Some surface flashing where the mold cracked during burnout. Very light, thin flashing. The core pins are removed from this piece also. A dust mask should be worn to avoid breathing any dust from the investment. Safety glasses or a face shield should be worn to protect your eyes. Here I'm using an air hammer to break out part of the core investment. The core must be removed from the piece too. Most times it's done with a hammer and a chisel. Now the dead drains are cut off with a silicon carbide blade on an angle grinder. It's the most expedient way that I have found for removing these. They could simply be cut off with a hacksaw. Same thing with the gates and the vents. The vents could be collected, and because they are the same metal as the piece, could be used as filler rod when the two sections are welded together. These vents could also be threaded and used to plug the core pin holes. Chasing is accomplished in various ways. Here, a ball-peen hammer and a cold chisel are being used to shear off flashing. When using the cold chisel to cut flashing, approach it at an angle. You don't want to run straight down the flash because the action is likely to tear metal out of the piece. Work at an angle to shear the flashing off. This is one of the dead drains being cut off with a hacksaw. The core pin holes are drilled out with a number 29 drill in preparation for threading with an 832 tap. You don't want to cut threads all the way through the thickness of the casting. Stop just a little short so the brass screw will lock into place. The brass screws will accept the pattern are pretty much the same as the casting. Once the screw is in place, it is nipped off. It could also be cut off with a hacksaw. And then tamped down to close up the threads so no thread line shows when the plug is filed down. They could be filed down to the surface of the surrounding area but I prefer to leave the bump of the screw just slightly above the surface of the surrounding area. The core pins were designed so they would create a pattern running through the piece. I'm using the necessity of core pins as a design element. Tamping down a little bit with the ball peen part of the hammer achieves a surface that is similar to the surrounding area. The chasing aspect of cleaning up a bronze casting is much like cleaning up a wax. I think it's very important to do all the chasing myself because I'm really working on the real surface of the piece, no matter how the wax was prepared. Sometimes you'll wish to leave a little bit of a flashing line on the surface of a piece, and you have the opportunity to leave file marks to revamp the surface, to pull up highlights, to enhance the real piece. I often find that visually there is one message, but tactily there is another. By the touch we can tell more of what a surface is than visually what that surface is. Chasing continues with the use of various rotary files and grinders. This grinder is simply a Sears Roebuck grinder purchased on sale for $39 5 years ago. An inexpensive tool, but since only one person uses it, there isn't much wear and tear on it. Of course, in a classroom setting, it wouldn't last very long at all. Files, as you can see, can be used in a non-traditional way. I use the edge of my files quite a bit, just the very corner. I find that it feels the form better, and in this area I wish to leave some of the file marks on the piece to emphasize the form. The file follows the form, the marks enhance that form. The top and bottom sections have been rough chased, and I'm preparing for welding by grinding the edge of the top section at an angle. so that when the top and bottom sections are fit together, there will be a good groove to receive the weld. In preparation for welding, the area to be welded should be as clean as possible, with nothing to contaminate the weld. We'll tack this piece in several spots before running the complete weld bead around this piece. This keeps the weld from pulling open on the opposite side of the weld. This is TIG welding, tungsten inert gas welding. The filler rod is silicon bronze, the same as the casting metal. So when the piece is welded, there won't be any color material distinction between the weld and the rest of the casting. Once the piece has been tacked in several different places, the process continues by filling in the spaces between the tacks. This piece could have been welded by the oxyacetylene process, but that process requires much more heat and a flux on the filler rod. TIG welding is considerably cooler, and you don't have to heat up as much of your casting. Simply concentrate on the area being welded. The heat is very direct. The bronze weld is very similar to the wax welds that appeared on this piece during its construction in wax. You have an excess of weld material that is then brought down to the basic form. A Makita grinder with a carbide rotary file is used to rough chase the weld bead. All this chasing could be accomplished with a variety of hand tools, hammer, chisels, and files, but if you have the opportunity to use any mechanical tools to expedite the process, you should take full advantage of them. Just as with wax working tools, every sculptor finds the tools that are most suitable to fit their aesthetic purposes. A variety of hand files, grinders, rotary files, chisels, emery paper. What those tools do and the personality of their marks contributes to the individual statement. If a surface feels right, usually it looks right. Once the chasing is completed, the sculpture is cleaned by sandblasting or power brushing with a wire wheel on a drill motor or flexible shaft. This is necessary to ensure an even patina. If using a wire wheel, be aware that the tines will shed from the wheel. Always wear a full face shield and gloves and operate at low speed. The patina for this piece consists of sulfurated potash, lump style, sometimes called liver of sulfur or potassium sulfide, and water. A piece of potash about thumb size is added to a pint of water. This will achieve a warm brown color. Potash is broken up into smaller particles to help it dissolve more quickly in water. The sulfuretted potash solution is sprayed onto the sculpture, starting at the bottom if you wish to avoid run marks. This patina could have been sprayed in several successive layers, allowing it time to dry between coats, causing the patina to become quite dark. The proportions of sulfuretted potash to water will also change the color. Less potash results in a golden brown, and more potash will result in black. With sulfuretted potash, simple adjustments give a wide range of colors. After the sculpture is dried, it is rubbed with medium-grade steel wool or Scotch-Brite pads. If the sculpture is to have another coat of patina, be sure to clean off any residue, especially with steel wool. Rubbing with steel wool brings up highlights on the bronze and greatly enhances the form of the sculpture. If desired, the patina can be further enhanced and protected by coating the sculpture with wax. I prefer tree wax, spelled T-R-E-W-A-X, applied with a soft cloth and buffed to a sheen. Often, it is necessary to mount a finished piece of sculpture to stabilize it or to enhance it with another material. To mount this piece, a letter F drill bit is used to drill openings in the mounting plates on the bottom of the sculpture, so a 5/16 18 tap can be used to cut threads through the plate to accept a 5/16 stainless steel screw. A paper template is made to transfer the markings where the holes should be drilled in the base. This method allows you to know exactly where to drill. The paper template is transferred to the base and marked where the holes are to be drilled. Since the screws are going to be countersunk, the information is transferred to the bottom. Recessed holes are drilled with a paddle bit so the head of the screw does not project. Body holes are drilled through the top. The mounting board can now be secured to the bottom of the piece.